Okay, good morning. Welcome to
MathyMath number 107.
MathyMath107. So yesterday I saw a neat thing on Twitter by our friend MathyMath107, and he said, "Hey, I just noticed something. I just noticed that if a Fibonacci number is divisible by 9, it is also always divisible by 8." And it was pretty cool, and I played around with it a little bit, and I was able to figure out why that's true. But I thought this would be a neat introductory proof problem. And we don't have to get all the way through it this morning. I'm just curious, more than anything else, how would you even begin to start thinking about this problem?
Well, I could find some Fibonacci numbers that are divisible by 9.
Okay.
So there's 1, 1, 2, 3, 5, 8. Well, it doesn't seem to work both ways.
Okay.
Because if it's divisible by 8, it's not divisible by 9.
Ah, interesting. Okay. Now, is that a surprise that it doesn't work both ways?
Well, no, it didn't say that here.
Okay, yeah. Like, if we have the sentence, if you are a car, then your color is blue. That does not mean if your color is blue, then you're a car, right?
Yeah. 34. 55, 89, 144. Well, this is divisible by 9 and 8.
Okay, how do you know?
9 times 16.
Okay. And what is it, 8 times?
It's 8 times 18.
Very good. Okay, so we found one, and it seems to work.
Well, none of these are divisible by 9.
Yeah. They sure were divisible by 8. Or one of them was. So, okay, so you found one, and it seems to be true. That's never a bad way to start, just trying to see what's going on.
Well,
But he's saying it's true for always, and I think listing all of the ones that were divisible by 9 out might take more than the 5 minutes I want to spend on this video.
So what can we say about this?
Yeah.
Well, they have to be multiples of 72.
Okay.
So, divisible by 72. Or, yeah.
Well, if it's divisible by 9, then it's divisible by 72 would be an equivalent statement.
Mm-hmm. But how can we find like a pattern for multiples of 72 in the Fibonacci numbers?
Yeah.
So that seems like it's going to be a hard way.
Yeah, well, what would be an easier pattern to look for?
Well, multiples of 9.
Okay. Well, here, don't write anything more out. So what would you do if you found a pattern for multiples of 9?
Well, I could list out the Fibonacci numbers.
Okay.
And list out the multiples of 9 starting from 144.
Okay.
And then Fibonacci numbers starting from 144.
All right.
And then just see if any of them match up in the same way over and over.
What do you mean by that, actually?
Well, if you list out a bunch of multiples of 9, and you list out a bunch of Fibonacci numbers, if you find that like there's a regular pattern for when you have a multiple of 9 that's a Fibonacci number, then you could probably say something about it.
Okay, interesting.
But how to do that would be the
Yeah.
question. Because the Fibonacci numbers would get really big.
Yeah, they get big pretty fast. So you're right. You're actually pretty close to the way I was thinking about this yesterday. And you've stumbled on exactly the issue. The Fibonacci numbers are going to get big quickly. And I'm pretty sure Fibonacci himself did not have a computer.
Yeah.
Do you know why I think that?
1700s.
More like 1200s.
So then how would we be able to do this without a computer?
Yeah, because the numbers get big really fast.
And you can't really see a pattern with them getting this big.
Yeah. Well, that's why this is a cool problem. So we'll talk more about this tonight, because it's actually a pretty neat technique, and it's a technique that you know how to do, but it's not obvious that this is the way to approach this. This is, it turns out, a number theory problem. So we're going to use some techniques from number theory. But we'll do that tonight, okay? All right, good work this morning, huh?